Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 4090 performance at 549. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Let's take a look at Blackwell. This is my show and tell. This is a show and tell. So this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere.
We would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. If we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. The blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. So, physical AI. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
Every robotics company will ultimately have to build 3 computers, fundamental computers. One computer, of course, to train the AI. We call it the DGX computer, to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation. These 3 computers are going to be working interactively. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. The next example, autonomous vehicles. The AV revolution has arrived. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars.
With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
We are going to have mountains of training data for autonomous vehicles. I think the next part is robotics. The ChatGPT moment for general robotics is just around the corner. This will be the largest technology industry the world's ever seen.
Robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations.
We're going to have mountains of data to train robots with. NVIDIA Isaac GR00T. NVIDIA Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. I have one more thing that I want to show you. Where's DGX-1? DGX-1 revolutionized artificial intelligence. And so I just wish that DGX-1 was smaller. And, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, connected to your computer. It's even a workstation if you like it to be. and you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. Thank you.